Golf courses worldwide rely on automatic irrigation to deliver the water and nutrients necessary to grow healthy turf. Delivering consistent pressure to the irrigation system is the primary challenge for water pumping systems, and Watertronics meets this challenge with our patented system of pressure regulation called the Electronic Butterfly Valve. Since its introduction, EBV systems have been providing surge-free electronic pressure regulation for thousands of pump stations, both as the primary pressure control and by working in conjunction with variable speed technology. Here's how the system works. A typical Watertronics pump station has one variable frequency drive that is sequenced between all of the main pumps. In addition, each of the main pumps is equipped with an EBV. Here the pump system starts when the irrigation begins and causes a pressure drop. As the lead pump starts and ramps up slowly under VFD control, the water is pushed up the pump column against a closed EBV. The air is pushed up the column and out the air release valve. Once the air is displaced, the EBV begins to open slowly and the VFD continues to ramp up to maintain system pressure. As additional sprinklers are turned on, the second pump will start across the line. The second pump's EBV remains closed until the air is purged out of the pump column. Once the air is purged, the EBV slowly opens fully, allowing the VFD on the first pump to maintain constant pressure. This EBV-VFD transition protects the downstream piping, fittings, and sprinklers from the detrimental effects of pump start surges and air entering the piping system. Now contrast this pump starting sequence with a similar pump system without EBVs. The first pump starts up smoothly with the VFD, but as the second pump starts across the line, pressure builds rapidly and the air in the column is only partially purged before the check valve slams open and a surge of water and entrained air is released into the piping system. The ongoing stress caused by pressure surges and entrained air entering the piping system will shorten the life of the pipe, fittings, and sprinklers, resulting in potentially expensive repairs to equipment and unscheduled downtime. Now that we've seen the pump startup sequence with and without Watertronics' unique EBVs, let's take a look at how an EBV system benefits the pump shutdown sequence. When the pump station detects a reduction in the flow demand, the second pump running cross-line begins to shut down. First, the EBV slowly closes, allowing the VFD on the lead pump to maintain constant pressure. Only after the EBV is fully closed on the second pump will the pump shut off. This perfectly timed EBV-VFD shutdown sequence eliminates overpressurizing of the piping system and eliminates check valve slam, resulting in more consistent water pressure delivered to the irrigation system. Once again, let's remove the EBV from the system and see what happens during a pump shutdown sequence. As the second pump shuts off, the check valve slams shut, creating water hammer and an abrupt drop in pressure. The VFD rapidly increases its speed, eventually returning the system pressure to normal, but the abrupt pressure fluctuation has already affected the piping system. These pressure swings and water hammer cause unnecessary stress on the irrigation system. One of the single most important benefits of the EBV system is that it offers complete pressure regulation backup in the event that the VFD faults or fails. Should a surge or fault disable the VFD, the pump will turn off and the next available pump will start across the line, fully pressure regulated by the EBV. Pressure will quickly be restored and the irrigation cycle will not be interrupted by a station shutdown. Let's again contrast this VFD fault sequence against a pump system without EBVs. When the VFD faults, the pump it is driving will shut off and all pumps will remain off until site personnel manually override the system or the VFD is repaired. At minimum, one evening's irrigation cycle has been lost. Each of the pumping sequences we've just seen, pump startup, pump shutdown, and the loss of a VFD while irrigating, underscore the critical role that Watertronics exclusive EBVs play to ensure that water, free of surges and entrained air, is delivered at a consistent pressure to the irrigation system every time. The benefits of the EBV system include extended life of the irrigation system, reduced irrigation system maintenance costs, and improved reliability, providing the peace of mind that an irrigation cycle will never be missed due to a VFD fault. So for a modest investment in EBVs today, the benefits of consistent pressure and system reliability will be realized now and years into the future.